Hey everybody, hope you're doing well, and I hope the news that you received yesterday, whether it was about the school being canceled for the rest of the year or the spring activities, didn't hit you guys too hard. It was a little bit of a rough day for me, um, but unfortunately or fortunately, life goes on. So what we're going to be talking about today is identifying bacteria. We know Anna Garcia was infected with something when she went to the doctor. We need to figure out what it was and how do we go about identifying it. We've already talked about gram staining and positive and negative and how to identify that. So now we're going to go on to the next step. Doctors use biochemical tests in order to identify the family and genus of the bacteria. So that's what we're going to be doing today. It'll be a relatively short day of notes. So biochemical tests can be done a number of different ways by the doctors. It could be a urine test, it could be a colon test, things like that. They are by far the most definitive way to identify bacteria. Um, Typically, what they'll do is they'll grab a sample of the bacteria, they'll swab like the back of your throat, or they'll take a couple drops of your urine and then put on the growth materia in the petri dish and let it grow for a bit and then run these different chemicals on it to find out what it is. Um, Usually, these tests identify the metabolic waste of the bacteria. So, what basically like the poop of the bacteria, or the stool of the bacteria, or the feces of the bacteria. God, there's a lot of names for poop. I won't say that's the word though. So it identifies the end products. And then some of the tests will determine a specific property of the bacteria species. So basically, you're going through and you're eliminating small groups of bacteria at a time until you get down to one species. Um, Most of these tests are going to be run in different orders. Sometimes you might need to do more than one test. There can be false positives, which means something tests positive when it really isn't. But for the most part, these are extremely accurate. And when we get to the actual tests that were ran on Anna Garcia, you'll see that there is a lot of different tests. There's different shortcuts that labs have developed to get answers quicker. The link at the very bottom will bring you to a website that shows all of not all of the tests, but a vast majority of the tests that can be ran on different bacteria. Again, I'm not going to test you on anything that's at that link. That is for your own perusal. Um, what we will be doing and what scientists do and doctors do is they'll take all these tests and they're going to go through what are called flowcharts. Most of you have probably seen these in your other classes before. We'll see what a flowchart is in a couple slides. But basically, the flowcharts are going to determine the genus and the species of bacteria. And the first thing you're going to start out with is what we've already talked about, whether or not the bacteria is gram positive or gram negative. Once we know whether a bacteria is gram positive or gram negative, we're going to find out which family it belongs into by looking at the test results, by seeing if they're positive or negative for different things. And once we know what family it is, we can find out the genus and the species. Here is the bacteria that we grew from Anna's sample. You can tell it is pink in color, meaning it is what? Yeah, gram negative. So it is gram negative. What shape is this? It's rod shaped. So is it cocci, bacillus? Yep, it's bacillus. So good. So just a little quick review. These are the tests that were ran on Anna's sample. You can see lots of tests done here. Just a couple of them, just kind of running through these. I'm not going to require you to know what each one is. Some of these you might know. If you ever gone in for, like, if you ever had a urinary tract infection, these are some of the tests that actually run on you. A couple of these again, glucose fermentation tests. It's just checking to see if there's any glucose in their lactose fermentation, indole, VP test, citrate, and ornithine decarboxylase test. Again, don't need to know what those are in this case. You can see over here underneath analysis, it's going to tell you if it is negative or positive. If we were in school at this time, we would be actually testing Anna's sample, and we do have all these chemicals, or most of these chemicals, so we'd actually be doing these tests ourselves. A couple more tests on Anna. We're going to jump back to this in a little bit. But so we run these tests, find out if they're positive or negative, and then we come to these flow charts. So again, this is what doctors actually use. There can be different versions of these flow charts. The very first thing that we're going to look at is, since we know it's gram-negative, we start with a gram-negative flow chart. The first test says is oxidase test, so we need to know if it's positive or negative. So let's head backwards. Oh, oxidase test turned up negative for Anna. So go back to the flow chart. We follow the line down to negative, and it says it's the type of bacteria is an Enterobacteriaceae, and it's on a separate flow chart. If it was a positive, we'd go to the left here, and we'd start working our way down. But since it's negative, we're going to go to our next flow chart. So now we're in that family Enterobacteriaceae, and it shows our very next step is a lactose fermentation test. So we need to know if it's positive or negative. So the lactose fermentation test, we look over here, and she was negative. So in that case, it says C lactose negative flow chart for the Enterobacteriaceae. So we go on to our next flow chart. I mean, we're just going with the flow, right, guys? Ha ha ha. So in the lactose negative ID flow chart, you have all these different bacteria that it could potentially be. We want to narrow this down. So now we look at our indole test. We need to figure out if it's positive or negative. We go all the way back, and she was negative. So we go down, follow the lines down. So now we look at our next test, and that's a urase test, and she was negative for that as well. So follow the line down. Our next test is going to be the motility test, and she was positive for this one. So now we follow the line down to the left to the positive, and we check for the H2S test. H2S test is right there in the middle, and she was negative. Again, follow that down, and it tells us the bacteria that Anna Garcia had growing in her sample is called Serratia marcescens. And again, don't quote me on that. I'm not the best with Latin. So looking at Anna's sample, we know the sample was taken from her colon. Sorry, let me back up. The sample colony that was grown is small and wavy with irregular colonies, and it had a raised elevation that looked reddish pinkish. Again, these would be things that we'd see in the classroom. Unfortunately, can't have you guys grow this at home because of the risk of getting sick. Using the gram results, we know that it was gram negative. And then with the other biochemical tests, it turned out to be that Serratia marcescens. I'm going to have you guys add this into her medical history, which I attached into the Schoology folder. So yeah, and I'll have that popped up here in a second. So for your assignment for today, other than listening to these notes and taking notes, is to fill out this medical history. The medical history itself here just kind of goes over Anna Garcia. You'll notice she had a high temperature, so that's considered to be a fever. She was breathing about 23 breaths per minute. Her pulse was at 102. Both of these are considered to be pretty high. And then what about the blood pressure? What do we notice? If you remember back to our diabetes unit, it's pretty high as well. So read through the case history. This gives a little bit of a background of what happened with Anna. And again, we're slowly making our way over to how did she die. If you want to send me a Schoology message on your guesses, I won't tell you if you're right or wrong. You're probably wrong, but you never know. I filled in the results of the 5.1.3 gross examination of the colony morphology for you. I want you to fill in the highlighted yellow parts. And again, 5.1.5, I also provided that for you as apology for the the video being a little bit long. And then finally, you have these 4 conclusion questions. Again, I got rid of 1 or 2 of them that were normally assigned. And I also gave you a little bit of a hint for the first one. And think about number three, might be a little bit of a harder one too, for some of you. Think about genetics and think about like how if you never met your, or if you had a long lost brother and you never met him, how could you find out if he was really your brother? That's kind of another way to look at that one. So hopefully you guys will knock this out of the park. It's due Sunday at midnight. And again, you don't have school May 1st or May 4th. And I hope that when we do get back to school that we'll be able to catch up. And again, I usually have food in my room, so drop in.